Alright, so let's try it again. So when you're given an identity like this one, what you often want to do is start on the side that's a little bit more complicated, which would be the left side here. We're going to leave the right side alone, so I'm not going to do much with this one. I'm hoping to end up with that. And the first thing that we can do many times is if you have a cotangent or a tangent, just write it as, well, the cotangent would be what? Cotangent is cosine over sine, right? Yeah? And the tangent is sine over cosine? And then multiply this. So when you multiply these two, this one cancels. So I just get the cosine of that. And here, when you multiply, you get sine times sine is sine squared divided by cosine. Now, one of these is a fraction, the other one is not. A lot of times it helps to write them as with a common denominator. So the denominator here needs to be cosine. So I'm going to multiply by the cosine of theta over the cosine of theta so that I get a common denominator. So when I do that, I get cosine theta times itself. So that's the cosine squared of theta. So now I have a common denominator. So I can add these two. And so you end up with the cosine squared of theta plus the sine squared of theta, all over the cosine of theta. Well, the cosine squared of theta plus sine squared of theta is how much? 1. And then you end up with 1 over the cosine of theta, and that would be equal to the secant of theta. So now I have shown that these two things are the same. So I've established the identity by only working on one side, which is usually what you do. You only work on one side. Okay, so how do you know how to do this? Well, hopefully you see enough of them and it starts sort of to click. Okay, so let me do another one. So here's another one. Notice that a little bit earlier I said you end up with this one a lot. See this thing over here? Okay, that's very similar to one of these other examples that we just did. So the side I want to work on, and sometimes it's hard to see what's more complicated, but let's work on the left side again and write these as their inverses. So they're reciprocals, sorry, not inverse. So that would be what? 1 over the sine of theta, right? Minus the cotangent is the cosine over the sine. Oh, that's a common denominator, isn't it? Yes? So this is 1 minus the cosine of theta times the sine of theta, or divided by the sine of theta. Then use the conjugate pair. Let's use 1 plus the cosine of theta divided by 1 plus the cosine of theta. If I do that, hopefully some stuff will happen, because I'm getting pretty close to what I want over here in the denominator. So what happens in the top? You get 1 minus the cosine squared of theta, conjugate pair. This is why we're doing it. Sine theta, and then 1 plus the cosine of theta. And whenever you see 1 minus cosine squared, well, either you want to factor it, well, we sort of just did the opposite of factoring, or you can replace it. So you can replace it in this case with 1 minus the cosine squared is the sine squared, right? And I'm one step away. I'm almost there. What can you do with the sine here and sine squared over here? One of them cancels, right? So this one cancels with the square, so you end up with the sine of theta divided by 1 plus the cosine theta. Okay? Here's something you do not want to do. So let's say you got to this point and you're looking at this equation and saying, well, I need to show that this thing equals this thing, right? Yes? Okay, what you do not want to do here is cross multiply, even though when you do that here, you get there's your conjugate pair, right? So you get 1 minus the cosine squared of theta equals the sine squared of theta. And you can then replace that with the sine squared of theta is the sine squared of theta. And if you did that on a test, I would cross it out and say, sorry, you can't work from left to right that way. Okay, you can't cross multiply across the equal sign when you're trying to prove an identity. So please don't do that. Well, some of you are going to occasionally do that. You guys okay with that one? So I'm going to do one more, and then hopefully you have a little time already in class to either ask some questions about previous stuff or go ahead and start working on this stuff. So last one. So they're getting more difficult, right? Out of these two, it's pretty easy to see which is the more difficult side. Which one's the more difficult side? Left again, right? Okay. So let's see what happens if you do this. So the tangent is sine over cosine, right? And then we get the cosine squared here. And then the cotangent is cosine over sine. Yep. Let's make a common denominator here. So a common denominator would imply that you have to... This one should be over the cosine, so over on this one I'm going to multiply by cosine over cosine. And here I need to multiply by sine over sine. Okay, why am I making a common denominator? Well, it's just easier to divide fractions when you have a fraction. A fraction divided by a fraction just means you can flip. And usually good stuff happens when you flip. So I'm not going to actually multiply much, so we'll just get this minus the sine of theta all over the cosine of theta, and in the numerator we're done. In the denominator we're going to have the sine of theta times the cosine squared of theta minus the cosine of theta. All of this is over the sine of theta. And then I'm going to flip that second fraction and hope that some stuff happens. And in this case, I think I'm going to be sadly disappointed that not a whole lot happens yet. So you flip your second fraction, and then you get this mess. Okay, and then what? That didn't help much, did it? So either you give up, you try something else. But in this case, I didn't really make a mistake yet. Can you see that there's a sign here and a sign there? So you can factor that, right? If you take the sine out of theta, what you're left with is the cosine of theta times the sine of theta. So if I took the sine out, I can take one of these out, so I still have the cosine times the sine, and then the sine of theta is taken out, so this is minus 1. Is that okay? And then I'm going to write this sine of theta right behind it. So that's the top. In the bottom, I get the cosine of theta, and then I'm going to, let's see, what can I take out here? I have a cosine squared and a cosine, so I can take out a cosine, right? That leaves you with the sine times the cosine minus 1. Now what happens? I'm a lot closer. Can anybody see what just happened? What you can do? This says cosine times sine, and this one says sine times cosine, but that's the same thing, isn't it? So this whole thing cancels with this whole thing. And sine times sine is sine squared, and cosine times cosine is cosine squared, and that will be an expression that is what we're after. So we're trying to show that it equals the tangent squared. So it worked. Now how do you know how to do this? I don't really know. You just practice and you try. And then if it doesn't work one way, maybe you can try it a different way. Okay, I'll show some more again tomorrow.